This is Group 1, Group Project Part 1, Visualizations for Big Data in a Global Economy. The group members are Lauren, Sylvia, Robert, Lizda, and Nick.
The objective of our investigation is to look at the key attributes that a company would look at in order to move operations to another country and reduce their operational costs. We found that many relevant attributes should be considered, and in order to get there, we used 3 different data sets. World Happiness dataset, pulled from Kaggle, and we used the 2017 tab. This report ranks 155 countries according to their level of happiness, taking into consideration the following factors: GDP per capita, family, life expectancy, freedom, generosity, and corruption. Moreover, we use the World Indicators database from Tableau and the Best Country dataset from Blackboard to conduct our investigation.
In our analysis, we took on the mission to identify countries that would be viable candidates for companies looking to expand their operations abroad. We looked at this in the context of the American aerospace manufacturing industry. The American aerospace manufacturing industry is currently experiencing unprecedented supplier cost increases due to supplier consolidation. These cost increases have a dramatic effect on the aerospace manufacturing industry's ability to turn a viable profit. The industry has also historically experienced high engineering costs associated with the development of new products. We looked to find a solution to both of these problems by moving operations abroad. In order to determine whether or not a country was a viable candidate, we looked at the following. First, does a country present a labor force adding value? Second, is a country's labor force viable and both productive? Third, does that country offer a business-friendly environment? In order for the aerospace industry to successfully move engineering functions abroad, they require labor forces that have a high level of education, but at the same time are provided at an affordable rate. Therefore, we looked at whether or not education levels drove increases in salaries. Based on the findings, we found that education levels do not directly correlate to the average salaries paid within the countries we looked at. A prime example of this is the United States, which possesses one of the highest educated workforces, yet they rank only in the top 10 of countries with the highest level of salary. Next, we looked at whether or not increases in salaries affects the size of a country's available workforce. What we found is, no, there does not seem to be any specific correlation between average salaries paid and the size of a country's workforce.
Does education level affect labor force participation? In analyzing this data, we wanted to know the importance of considering the education level in the country we choose to expand in. What we found was that no, education level does not affect labor force participation, as there is no clear trend between countries that rank low in education level and their labor force participation. If we take a closer look at countries like Mexico and Czech Republic, we can see that they have some of the highest scores in labor force participation, but not necessarily the highest score in education level, which tells us that they are viable countries to consider when choosing manufacturing locations. Does education level affect productivity, or GDP per worker? As we found no correlation between education level and labor force participation, we felt it was important to evaluate if those same countries would give us the best ROI from our employees as well. What we found was that there actually is a correlation with countries that rank low in education level and their productivity. If we take a look at Mexico once again, we see that although their education level score didn't affect their labor force participation, it does affect their productivity. Of course, we still found some outliers like Austria with a low score in education level and high score in labor force productivity, but overall, the trend from lowest scores to highest scores in education level and productivity is upward.
Next, we wanted to understand the fundamental question, if you pay more, do you get more? In order to assess this, we looked at whether or not high salaries drove higher productivity or GDP. In the countries that we looked at, higher salaries do not always end up with higher GDPs, but oftentimes higher salaries result in countries having higher GDPs. We thought this was an interesting point, therefore we dove deeper into GDP in the following slides.
When looking at the distribution of average GDP per capita, or higher labor costs, the three top countries are Qatar, Norway, and Luxembourg. The aerospace industry is highly regulated and very risk averse, so it is very important to identify the countries with the lower corruption rates on its distribution. We can see that Rwanda, Qatar, and Singapore are the countries with the highest government trust, hence the lowest corruption. Ease of business describes how friendly a country is to start and conduct business. A score of 1 means the country is very friendly. Therefore, the lowest the score, the better it is. Singapore, Hong Kong, and New Zealand are the top countries in the ease of business ranking. When looking at the distribution of countries and their correlation to government trust and GDP, there are three main clusters. However, we should pay close attention to cluster number 2, the one in orange, specifically the countries on the right of the red line. Those countries are the ones with the highest trust in government, or less corruption, and average GDP, which could lead to a lower cost. This visualization shows that there is a significant correlation between GDP per capita and ease of business. As you can see on the graph, the countries above the line represent most of the countries with high GDP and are very friendly to conduct business. The countries with the highest GDP and most friendly places to conduct business are Singapore, United States, Norway, and Denmark. This analysis was taken directly from the ease of business clusters from Tableau. There are three main factors which could help understand in depth the friendliness of a given country to start and conduct business. These three factors are business tax rate, hours to start business, and hours to do taxes. The lower these indicators, the easiest it is to conduct business in the country. On this analysis, we are taking a look at two different visualizations of our clusters and how ease of business and corruption correlate. Some of the countries, such as Singapore, Denmark, and New Zealand, are considered to be friendly or very friendly for businesses and have developed strong sense of trust on their government, which means very low or zero corruption.
In order to expand into a foreign country, the aerospace industry would be required to make a large training investment. Therefore, we thought to investigate the vitality of different countries' workforce. In order to assess vitality, we analyzed the cost of healthcare in relation to a country's average life expectancy. In this report, we found high life expectancy was not necessarily influenced by healthcare cost. In this visualization, we see the three highest life expectancies as Japan, South Korea, and Spain, all with healthcare costs around the median value, while the three highest in healthcare cost, Switzerland, Greece, and United States, have an average life expectancy that ranges throughout the spectrum. In further analysis, we compare the average amount spent on healthcare to each country's average life expectancy. Clustering shows that there are two significant clusters. In Cluster 1, we have countries that have a greater average spend on healthcare at $617, boosting their life expectancy well over the other cluster to an average 83 years old. In Cluster 2, the average spent on healthcare is only $310, and those countries' average life expectancy is much lower at only 67 years old. 24 countries fall into Cluster 1, with only 5 countries in the lower life expectancy of Cluster 2. Again, with the significant investment the aerospace industry will be making, we thought it important to assess the available labor productivity versus the required healthcare investment. In this slide, we're looking at the average labor productivity. Some countries begin to stand out as being more productive while remaining lower in healthcare costs and longer life expectancies. One country, for example, Ireland, is second in productivity while remaining low in healthcare costs, but average for average life expectancy. Interestingly, Japan, at the top of life expectancy, has no form of compensation, falling about middle of the pack in productivity and one of the lowest in cost of health care. In the visualization, we can also see compensation in the darkest color having the highest compensation. Another way to look at productivity is to compare dollars spent to compensate the workforce to productivity. In this visualization, I use the columns again as country, but then the rows of productivity and average compensation. Here we see that the highest in compensation is not necessarily the most productive country. Ireland may lead in compensation, but they fall second to the United States with the best productivity. Likewise, while the US has the best productivity, they are third in amount spent on health care, likely due to their near half of the lead in compensation, and almost last in life expectancy. Here, in our final slide, we will look at a linear trend model computed for health life expectancy given the average cost of health care. In this visualization, I have taken the data for life expectancy and compared it to healthcare cost, and then changed it into a scatter plot, removing the aggregate measures to find any correlation. Once the scatter plot was created, I was then able to use Tableau to describe the trend model and get the data related to correlation. Here we can see the R-squared data at 0.16, which when you calculated the square root, you get a correlation of 0.40, which is a positive yet medium correlation and not very significant.
In closing, we plan to take the data that we've just covered and truly apply it to the aerospace industry's need to expand abroad. We want to better understand the risks and the benefits that come with such a decision. Our ultimate goal is to come up with a process in which a company can take a more informed approach to looking at overseas expansion. We hypothesized that by moving manufacturing and engineering functions abroad, the aerospace manufacturing industry can increase their profitability and returns significantly. Thank you for your time. This concludes our presentation.